Missing completely at random is the best kind of missing data you could have. So this is good. Because if the values are missing completely at random, then it's just as if you have a smaller data set, right? Like if I have a pile of surveys that is supposed to be a representative sample of my target population, and then 5 of them fall into a puddle, well, if it's a random 5, fine. My sample is just 5 units smaller than I planned, but that's okay. Losing those 5 does not change whether my sample is representative in that case. So you can think of missing completely at random as if you just have a smaller data set. And that's pretty good, right? That seems all right. Now, after we go through the different types of missing data, we'll go through and talk about different strategies for handling missing data and whether they work for these different missing data types. But let me just say here, missing completely at random is nice because you can just ignore the fact that you're missing some of the values, right? It's no problem. It's not going to mess us up in any way if our sample size just got a little bit smaller. So spilling coffee actually is the best way to be missing data. The second type of missing data is called missing at random. And so here I think you're seeing why perhaps these names are not ideal, because one is missing completely at random and then a different concept is missing at random. So this is MAR as opposed to MCAR. Here's the idea. Whether a value is missing is correlated with other information in the data set. So we have an example of this already, right? This is our Chinese high school students example. Right? Whether I observed the number of people in someone's family is correlated with whether they were from China. Okay? Right? It wasn't just that that some of the students in my class completely at random didn't fill out my survey. It was that the type of student who didn't fill out my first day survey had a particular answer to the third question, where are you from, right? The idea with missing at random is you can see if you want to try and see if you can leverage this correlation. If whether a value is missing is correlated with other information that you do have, perhaps that can help you make some guesses. If you're thinking about mathematically how this would work, let me just give you a clue. The idea here is that missing values that are missing at random are a simple random sample from a subset of the data where the subset is defined by variables you do observe. So the subset is defined by observed information. So let's think about that. So for missing completely at random, I said, okay, this is as if you put all the units in your data set in a bucket, randomly drew some and said, all right, these are the people whose answers didn't arrive. This is like, okay, I'm going to take everybody in my data set and put them in buckets based on where they're from, because I know where everybody's from. And then I'm going to reach my hand into certain buckets, maybe the bucket of people who are from China, and randomly take out some of those people's values. So the idea is that with the Chinese high school student example, it's not true that it's not equivalent to putting all the students in a bucket and randomly drawing some of them to not have their family size observed. But this is equivalent to putting all the Chinese high school students in a bucket and randomly drawing some of them and throwing their values away. That's missing at random. There's a correlation between whether the value is missing and some other information, but I have that other information. And so it's as if I split the data up into buckets based on some information that I did have and then drew missing values, drew units that would have missing values from those.